So we now turn our examples to limits involving infinity minus infinity. And so these are the ones that tend to give students the most trouble, these infinity minus infinity limits. We begin with an example, and there's really two approaches we can try, and which we try depends on kind of what we have. So let's consider an example first here, looking with a polynomial. Let's say we're looking at the limit as x goes to infinity of x cubed minus 3x squared. So what I try to do is to try and factor something. So when you look at this, if you plugged in infinity, you'd have infinity cubed minus infinity. So this is an infinity minus infinity limit. Okay, so we have that issue that we're dealing with. So what we do is we try to do some type of factoring. Now in the case of a polynomial here, the idea is actually that we factor out the largest power I can pull out. So we'll rewrite this as limit as x goes to infinity of x cubed. Largest power that's the present, that would make this 1 minus, and then that would actually become 3x to the minus 1, which would be 3 over x. Now at this point, this is just an infinity still times 1 minus 0. So we're able to actually just work it out. This is just going to be infinity times 1, which is just going to be infinity. So of course, that's something we already knew, that with a polynomial, the largest power dominates what's going to happen. The largest power dominates in a polynomial what's going to happen. But I just wanted to kind of go through that limit because it is an example of an infinity minus infinity limit, and we're solving that by factoring. We're solving that one by factoring. Okay, so let's turn to one that's a little bit more complicated, but it uses the same kind of idea. So here we're looking at the limit as x approaches infinity of x minus the square root of x squared minus 3x. So here, as x goes to infinity, of course x will be going to infinity. And inside the square root here, the only thing that really matters is kind of the x squared here, because he's the largest power inside. Square root, so x squared is going to go to infinity. Square root of infinity will be infinity. So we are once again dealing with an infinity minus infinity limit. So here's what we do. I'd sure like to be able to have something I can take out of everything. I'd sure like to have something I could take out of everything. That's what I'm kind of looking for. So with that in mind, I realized that the dominant piece here is the x squared. And if I had square root of x squared, that would be closely related to the x. So what I start to do is trying to get something I can pull out is inside that square root, I'm going to factor out an x squared. Kind of like I did with the polynomial. That would leave me with 1 minus 3 over x. Now, when it comes to square root of x squared, we know that that is absolute value of x. But since we're approaching positive infinity, that means that the values we're dealing with are only positive, then we know that absolute value of x is equal to x. So square root of x squared is just equal to x. If you were doing limit as you go to negative infinity, then we would say when x is negative, square root of x squared would be going to negative infinity. Okay. So we can actually rewrite that now as the limit as x approaches infinity of x minus, and now the square root of x squared will just be x. So x square root of 1 minus 3x. Okay, and now we factor out that x that we're looking for there. Get it out of the problem. So now I have x times 1 minus the square root of 1 minus 3 over x. And no longer do I have an infinity minus infinity limit. What I actually have is x is going to infinity. This stuff here, well, the 1 is going to go to 1. The 3 over x will go to 0. So this is actually going to be 1 minus 1. So this is actually now transformed into an infinity times 0 limit. So by factoring, we will get the infinity out. That left us with a 0 on the inside. So we had an infinity times 0 limit. And now we know how to handle that because that's what we talked about previously, right? We looked at these infinity times 0 situations, and the key was to rewrite it as one of the things divided by the reciprocal of the other. And again, we can pick either one. One will make it an infinity over infinity limit. The other will make it a 0 over 0 limit. The thing we'd elect to put on top is the thing that's probably a little more complicated. So in this case, the thing I would elect to put on top is the piece that's a little more complicated. It's going to be a little more involved as far as taking the derivative, because otherwise, if I put the more complicated thing as the bottom, it's going to be 1 over that stuff, making the derivative process even more complicated. Okay, so with that in mind, I would write this as the limit as x goes to infinity of the top, 1 minus 3 over x. Instead of writing square root, I'm going to go ahead and write that as a power to the 1/2, right, over the reciprocal of the other one. So over 1 over x. That way our problem now transforms into a 0 up top over infinity limit that we can now finally apply L'Hopital's rule to. Finally apply L'Hopital's rule, take the derivative of both the top and bottom. So as we do the derivative of the top here, derivative of 1 is 0, so that goes away. We will carry the negative sign through. Carry the negative sign through. That was out front. And now we have limit or derivative of 1 minus 3 over x to the 1/2. So we would multiply by the exponent, 1/2. That stuff to the minus 1/2 times the derivative of the inside, the derivative of negative 3 over x, negative 3 over x. So that would be negative 3, right? And that's x to the minus 1. So for the derivative of x to the minus 1, we would multiply by minus 1, and we would drop the exponent by 1. So the derivative of that stuff on top derivative of the stuff on top here is going to be the minus derivative of the outer function, 1/2. That stuff now to the minus 1/2 times the derivative of the inside. On the inside, that's 1 minus 3x to the minus 1. So minus 3, derivative of x to the minus 1 be multiplied by minus 1, and then x to the negative second. Okay? And then The bottom, we just have the derivative of x to the minus 1. So that, of course, would just be minus 1 times x to the minus second. And so that's going to cancel with the other minus 1, x to the minus second on top. And now we've gotten rid of our problem that led to our 0 over 0 limit. It's now vanished from the problem. So what I now have is the limit as x goes to infinity. That'll be a minus and a minus. We'll make that positive 3 times 1 minus 3 over x to the minus 1/2. All of that divided by 2. And so now we've gotten rid of the issue. We can let x become infinity. When it does, that'll just become a big fat 0. That'll be 1 raised to the negative 1/2 power, but 1 to any power is just 1. And so therefore we get 3 over 2. We get 3 over 2. Okay. And so again, we see the limit here is just 3/2, positive 3/2 on this particular example. So be very careful. It's easy to make sign mistakes and things. In fact, when I did this another time in the past, I actually got a negative 3/2 because I lost the sign out front. So be really careful. It is easy to make a sign mistake. We can verify graphically that we do have the right situation. You can see as we go out to positive infinity, get really big in the x direction. Right, this is leveling off to 3/2. Leveling off to 3/2. By the way, had you been doing a other limit, it actually the other direction does not approach a numerical value. It actually goes towards negative infinity. It actually goes toward negative infinity as you get big in the left direction. Okay, so and that's because of what would happen when you evaluate this thing that you factored out. That would actually make it a plus. And if that's a plus, this is no longer an infinity times 0 limit. It would actually be an infinity times 2 limit. And so therefore, it would actually be approaching negative infinity, actually be negative infinity times 2. So, because x going to negative infinity. And so that would actually go to negative infinity. We'd actually see that graphically here in this picture, that it is just continuing down forever. Okay. So that's just to kind of give you a little idea of that. Okay. So, but the idea was we wanted to find a way to have something that we can factor out. Something that we can factor out. And so the key was doing that, to get something we can factor, which will transform it into a limit we can work with. Either an infinity times a number or infinity times 0, okay, which we can then work out.